So Aloisio asked us to talk a little bit about his work and introduce him, so it's not going to be too hard given the audience. Myself, Ricardo Paz de Barros, and another colleague of ours who is now president of Getúlio Vargas Foundation, were his first three students in IMPA, here at IMPA, in 1981, 81. 81. So, has a long way. We go a long way. Obviously, his academic career is quite impressive, and he also has a very long list of students that have worked with him. I will just say a few words about some works of Aloisio that really impressed me. Starting with the central limit theorem in Banach spaces, so with the Verhist-Genet. But I think the first paper that really impacted me, although there are many, each person has their own likes and dislikes, but the first one that really impressed me a lot was the lack of Pareto optimality, the need for impatience. If you don't have impatience, you don't have Pareto optimality. And this sounded to me like a very profound and there are profound and deep implications about how we view the world. Then soon after, he has this once but not twice differentiability of the policy function, which now is well known, but it was something which was quite remarkable because many results depended a lot on assuming the value function was twice continuously differentiable. And a lot of these results don't hold, at least not with the same proofs. Then there are many other papers, but there are two strains of papers that I think are very interesting. One is where he relaxes the usual concave assumptions and single crossing properties and solve moral hazard problems and self-selection, adverse selection problems, which I think are also quite interesting, and also the introduction of a lot of work with Mário Páscoa, mainly on collateral, Mário Páscoa and Paulo Klinger Monteiro on collateral. And finally now he's coming to use a lot ambiguity in his works, which is dear to my heart, obviously. So I'm also quite pleased with that, but for personal reasons I have to say a lot. I'd like to mention some of the aspects, perhaps, which are not quite well known for you here, of the practical implication of his works. In fact, Aloisio, in the last 10 years or so, has had a lot of impact on economic policy in Brazil. I think one of the first papers, one of the first results, which was very, very important for us to understand how macrodynamics in Brazil work, was a result of his work in the Central Bank of Brazil, when we posed him the question, what should the inflation target in Brazil be by 1999? And his answer was, after some time, higher than elsewhere, because we have very hard fiscal problems that are embedded in our constitution and our laws, and the only way to deal with them without a lot of costs is to erode it through a little higher inflation than other places. And the inflation target in Brazil has been higher than elsewhere for quite a while, and still it is, at least until 2018. So it's a very practical and highly important paper. Also, he has worked with many co-authors in the auctions and pointing out problems with the public sector auctions of electric utility generation, and also on the oil, you know, the pre-salt, as we call it, oil, you know, sale of oil rights. He pointed out very important problems with these, and these important problems actually came out to be true because the government did not listen to his very sound advice. But also he has been very important. He was actually fundamental in the approval of the Brazilian bankruptcy law in 2005, which completely changed the landscape for loans for corporations in Brazil. And it has had an immense impact on economic efficiency and credit here. His latest work deals with optimal indirect tax in the presence of informal markets, and also infant education, which he has been quite an advocate of early education, and he has been heard. So we thank you very much. We congratulate you, and you know, I pass to Ricardo, who is also one of his students.
So first, thank you for to the organizers to have the opportunity to be here to host this very important lecture. And I'm just going to concentrate on more unknown things about the work of Aloisio. One was I was doing an empirical study of the was working with the Minister of Technology and Science, and what was the correlation between business cycles and science. And we say, well, that's a very important thing, and we need a long-term time series. So we have the time series for the Brazilian GDP or inflation or wherever. We need something for scientific research. So we need a 40 years time series. So why not taking Aloisio academic production as a proxy for the scientific production? And so we compute the correlation of his academic production with life cycle, with business cycles in Brazil that you know are huge. And you know the business cycles in Brazil are really huge. And him as a major, most of the time, a public employee, his salaries were fluctuating very sharply. And the institutions were fluctuating very sharply. So we was expecting to have a very decent correlation. The correlation was zero, absolutely zero. So I say, well, let's compute so the covariance was zero. So I said, well, let's compute the correlation. So we have to divide by the variance, or the standard deviation. And then the computer could not compute because the variance was zero. So actually, if you take his curriculum, you're going to see that he produced one, two papers published in the important journals. And but if you average every 2 years, it's always kind of 3 papers in major journals. And so he's a very bad example for the science, that he's saying that I don't care how the economy is, or how much people are paying me, or what's going on in the country. I'm going to produce the same thing anyway. And it doesn't seem to be, we put some dummies where he was in the world, and it doesn't matter too. So if he's in Brazil or France or US, he produced essentially the same thing. One other thing that you probably don't know is that before Aloisio, Brazil was the science of economics in Brazil. Actually, we had very good economists one generation before, and Simonsen was one of the leading guy that was extremely smart and very knowledgeable about everything that was going on in the world. But we're very close. I mean, we have very little, actually, contact and connection. So what we are having today would never occur before actually Aloisio started to work in Brazil. He came back from the US and started working in Brazil, and he started opening up the mind of Brazilians, and now I think has many generations that follow him, that actually the scientific work in Brazil, it's the internationalization of the scientific work on economics in Brazil was launched fundamentally by his example and his leading over this period. My third point is that I think what I learned a lot with Aloisio, it's that there is just one science. There is not applied science, theoretical science, abstract science, concrete science. There is just science. And he's a person that in the Brazilian Science Academy has had a major impact on putting all sciences together. And the book, actually the work that Sergio was referring, it's an amazing effort where he was working with neuroscientists and cognitive psychologists, even educators, which the hardest scientists to work with. And he came up with a book on childhood development, putting all those guys together. That's really a reference. And you know, today Brazil has, as used to be the case, Brazil has one of the most advanced legislation in the world on many things. Difficult thing for Brazil is to implement the legislation, but in particular, based on this work that he did at the Science Academy, Brazil has now passed and has been approved by the president a new law about the promotion of childhood development, that is kind of an example for most countries in the world. And last week we just have a conference in the Brazilian Congress, people coming from very different parts in the world actually celebrating how advanced is this legislation. Of course, there's a lot of, we need the money to implement it, and we need the will to implement it, so we're going to see what happens. But most of this legislation was also very influenced by this important contribution of the Brazilian Science Academy by this work that was that Aloisio was the leading person, together with scientists from absolutely all areas of science. So I think he's I think we can measure science. In general, we measure science by how much people have produced. We are very product-oriented field or industry. But for a scientist to be really important, it's as important as how much he has produced. It's how much he has influenced the following generations. And I think Aloisio has a huge impact on all the Brazilian generations after him in economics. Thank you.
It's a great honor for me to be here on the occasion of Aloisio's birthday. The advantage of going last is a number of things I had wanted to say have already been said. But I was going to talk about 3 different areas of Aloisio's work, and I was very impressed by his work on bankruptcy and the influence it's had on Brazilian policy. Let me mention 2 others, though. A number of years ago, he started working with a former student of his, Marcia Leon, and more recently with Rafael Santos, thinking about Brazilian debt management policy. And in fact, and it's particularly apt because here at this SAET meeting, we have a special issue of economic theory coming out in which on debt policy, in which the 3 of them make a beautiful contribution. And what's interesting is Aloisio is not just such an excellent mathematician and theorist, but he's a very careful applied economist, and it really is looking at a fundamental issue. What's important for getting into problems with debt is how much borrowing you need to do every period. And he and Marcia had made that point early on and did very careful calculations for Brazil. And more recently with Rafael Santos, they're looking at the denomination of debt. And so his work not only was very influential in bankruptcy policy, but in debt management policy. Last year, I had the year and a half ago, I had the honor of introducing Aloisio for a plenary session at the Licea meeting in Sao Paulo. And there he talked about his more recent work, and I have to admit a selfish interest in this because we're beginning to talk about this together on risk-loving individuals. And I had a certain attitude towards risk-loving that I picked up years ago from looking at classic texts, which were in more the consumer theory point of view, that risk lovers were just crazy people. And they might be, but they're very valuable in general equilibrium. And this is the insight that Aloisio has had. They provide a service to the rest of us. And the presence of risk lovers can make the whole economy quite a bit better off. And so we're talking about extending that in an overlapping generations framework, and I think it could be it could change our attitude about risk lovers. Rather than making fun of them, we'll welcome them for providing us with insurance services. But you know, Aloisio, I first met him about 35 years ago. And over time, we've gotten to know each other more. And if we celebrate his life, it's not just as a great scientist and economist that he is, but such a warm and wonderful person, and somebody who likes very good food and wine. And those are very worthwhile attributes. So I want to congratulate you on your birthday, Aloisio, and thank you for being my friend and inviting me here. Happy birthday.
Well, thank you all. My first class, really in IMPA, was Sergio, Ricardo, and Carlos Ivan as the president of Getúlio Vargas. And it was really great. Some people already said that I could have retired after that because they did such a great work for Brazil, for scientists, and then there's, and thank you also, Tim, a lot. He's a very good friend. And then I think I made a mistake because some students said, "Oh, Aloisio, I like one talk of you I like. Why don't you give something similar to that at the end?" And then I accept it, because after such a good introduction, I don't know if I can be able to keep it up. But anyhow, since I promised, I cannot default, though default is not that bad sometimes. But I have to deliver the talk, okay? So, so that's what I'm talking about is the work that we've been doing here in IMPA in the last decade or so with lots of students and co-authors. So it's the future of general equilibrium from the perspective of what you're doing here, the role of preference. The future of general equilibrium might be in many directions, I hope. I'm an optimist about it. But I'm talking the role here of some preference, introduce new preference, and some financial institutions. So that's I'm related to. So this, preference, I'm not talking that much, just a little bit awareness that the work I did with Pasqua, Lovinsky, Gama Torres, we have some paper in jet, and then the idea that I just knew ambiguity of Gibot, Schmeiler, and so forth in an infinite horizon. The prices have a bubble component, so if you take general equilibrium, that automatically generated a bubble that people. And these preferences are so prevalent nowadays, ambiguity. So this, another type of work that I did with this new preference come from decision theory with Heleno Faro. Holanda was my previous last student, and Chatanov, my co-author, and how to identify market friction from the price rules that they generate. They come certain characterizations. They might come from incomplete market, or from bid-ask, or from a nowadays doing something that's some taxation in the financial market. They generate certain characteristics about this price rule. Another thing is this risk loving that Tim was mentioned about. Many times in general equilibrium, you are raised to believe that the equilibrium doesn't exist when you have a risk loving with convex preference, convex utility. And here is an example in the Edgewood box. As long as you have aggregate risk, so because if that's not, it doesn't have aggregate risk, the risk lover would like to just go for one corner. That's today and tomorrow. Tomorrow there are two states of nature. And the risk averter would like to diversify, so it doesn't exist. But if there is aggregate risk, the price where there is more endowment will be lower, the risk lover will go that direction, but will leave a little bit for the risk averter, so equilibrium still exists. And this is a quite extreme case, but it was a surprise when we come out to some student with this. The old textbook in general equilibrium doesn't contain all the truth. That's what I like. I'm a classical general equilibrium. So, and this could be generalized for Friedman-Savage type. When you have a part that you're a risk lover, then you are a risk averter, and this type of graph also is important nowadays for some people in behavior. They say loss aversion and so forth. So, and then many people found the loss of empirical, Salanier and the PGP, and then also Walker and many other people from lab experiment that people behave like that. It's a little bit like Friedman-Savage. And then still can incorporate that in general equilibrium. So equilibrium exists, and then can characterize it. So I think it's quite comforting that all this new preference that appearing, both from decision theory and some of them behavior and so forth, can be incorporated in general equilibrium. Not everything, but some of it. So I think our theory is bigger than you thought. And then to look what characteristics does it generate, for example, bubbles, no? Awareness is, because awareness, you have something that's lower semi-continuous in upper semi-continuous, sorry, in the market topology, but not lower, just in the strong topology. So equilibrium still exists, but equilibrium have this bubble component. So I think it's comforting to know that you can cover other cases that in classical general equilibrium just ignore. So that's a part. But what I'm more involved that I'd like to talk here more today is the new institutions. Institutions is a very commonly used word in economics nowadays. But for me, institution is just changing the budget set. Okay? That's from the classical general equilibrium, can either change the preference from the budget set. And so that's the idea here. So we start essentially with a narrow the broad economy, then shut down all the markets due to lack of commitment. And then what can you do? And then introduce some simple rules, some simple mechanism design, if you want, some laws, simple laws or simple devices, and see how this economy do in terms of welfare. So there are the collateral model that Felix talked about, and then we have a joint paper, and then this model we apply with Woodruff, with Schommer, to non-conventional monetary policy. If you have a collateral constraint economy, sometimes you can do better if the government buys the collateral backed asset and change the collateral constraint, and there's a room for Pareto improvement. The Wallace observation that all the central bank intervention neutrals doesn't hold anymore because you have financial constraint. So, and the collateral introduce lots of financial constraint. So there's a room for active role for that. And then the bankruptcy law. We did lots of bankruptcy law from empirical point of view, for practical and so forth. But I would like to take a more theoretical look today. What does it do for general equilibrium? Simple bankruptcy law. So this is the, I'm going to focus now my last PhD student. So those are my first, not PhD, but my master student, but I want to focus today my last PhD. He just defended last February, I think. And that's Mauricio. He's here somewhere. So that's my, we introduce bankruptcy equilibrium, okay? So let me make a short review of the lack of commitment models, and then to focus on the bankruptcy one. There is this penalty in the utility function. There's Janakop, Dubé, and Schubik. Actually, like Felix pointed out, I had the earlier paper myself in the econometric where I used this, but I knew the paper, I should mention Schubik and Wilson, I think. But anyhow, Janakopoulos made this in econometric, so I did that before, but it was not mine. It was Schubik and Wilson, not Chuck Wilson, Chuck Wilson, sorry. Then the debt constraint, Kehoe-Levin. Agents are excluded from financial market. So let's go back. We have Arrow de Bro, then given that you cannot enforce contract, the court are not that great. One thing that I don't like about classical economics, then the courts enforce it, then the courts enforce it. Well, I live in Brazil, there is no court, or very little court. So I have to think more about situations where there's not a court to enforce the contracts. So the penalty utility function is a good model. That constraint that Guillaume Levin exploit a lot, if agents don't play, they exclude from market. That's a very important device, but it's not the only one that you observe in reality. So but that's very important. I particularly like the Skoll-Kilho model. There's a follow-up of that. I did some work about the sovereign default. No, the team mentioned a little bit that manager, but I was particularly interested in the dollarization that many people claimed that was very good for Brazil, very good for Argentina. Well, I mean, I was skeptical, and it was very bad for Argentina, I think. And so this is a very simplistic way of having macroeconomic stability. You cannot just borrow the macro stability of some other country. So anyhow, so this is I use this model of Skoll-Kilho. So this is exclusion for market, in some sense. Then the collateral model, Giannacopoulos, Zane, and I had a paper early on in econometrics, and then more recently with Kubler and Schommer. Then to borrow, you have to put up collateral. That dominates the credit market scene in some sense. To borrow, you need. To buy a house, you need to put up the mortgage, no? The house is a collateral. And then there is a bankruptcy model that's less well understood, and that's what I'm going to devote today. The bankruptcy model, I had the one early one with Mario. We'll have this non-convexity, and then we'll put the infinite number of agents, and then like Alma style. And Sabaval, that was here in this meeting, has a paper like that also. And then have an unsecured debt. And credit and debt rights are defined by bankruptcy law, essentially a garnishment of your endowment. I did a little bit of that, not exactly the same model, but some, and then more recently somebody at Harvard did the bankruptcy law in the US, regression, and to see what's the exemption rate, to have several states and so forth. But going back to some literature that I'm going to make the application of the paper today is the systemic risk. Fragility is present in, as a shock that might extend to the whole system. There's Island Gate, more recent there's a Semoglu and some co-authors in AER. And this is, people start paying attention to understand systemic risk after the crisis. I think it's a very important problem, no? And that's what I want to address. But for the model, they don't have general equilibrium. Many things are exogenous. Sometimes they have a little bit endogenous, something exogenous. So contagion is always bad. Systemic risk is always bad. What comes from this literature, that you have to take more serious bankruptcy. You don't want to push it away from our economy, because they play the role. Your trading set expand if you let bankruptcy in, if you let default in. So that would be, if you let systemic risk in, perhaps you're better off. That's what we show. That's the main final example. So the outline of this paper is adding unsecured asset to collateralize the economy, increase the chance of implementing arrow de Broglie. So first question to have, no, is if I can implement arrow de Broglie still, although have lots of financial friction. Perhaps you can. Not always. But bankruptcy, my Pareto dominate non-bankruptcy equilibrium, it actually might be efficient. And contagious. You have an example, the default without contagion, default with contagion, and default with contagion, Pareto dominates the non-contagious equilibrium. So it's very simplistic to avoid And many people in the US, I was visiting Minnesota recently, there was a big meeting, and then the president was promoted, get away with big banks, get away from systemic risk. And then it's not that simple. That's what I want to point out in this example, okay? I don't have the two, obviously, very far from calibrating anything, but theoretical example. So our model have two periods, uncertainty in the second period. Each state there is spot market and a perishable and a durable commodity. There are J secure asset that made promise RSJ and collateral requirement are CJ. That means collateral requirement, in order to borrow, to sell this asset, you have to put up collateral. And there are some unsecured that made some promise RSJ. Unsecured delivery is DSJ for individual I, and then there is a delivery rate that's going to be determined in equilibrium, K. And so they are given by this formula here. That's what the people actually pay. This is what people promise to pay. This ratio here is what asset J in state S pays back to whoever invested there. And there are two regulating parameters. One is the seizure rate. How much can people garnish from your endowment, or firm, or whatever. And there is a debt constraint M. So unsecured debt is like that. You promise that, that's your debt. All financial income can be garnished. So all financial income might be garnished. So the total punishment is all your financial income plus a fraction of your endowment. Has something to relate with personal bankruptcy in the US. Not exactly, but it's a way of start thinking about it. So delivery on secured debt will be the minimum. What you do, you're going to be punished. You have a debt. The minimum, you do it. So it's like collateral, except now your collateral is part of. You could interpret that. That's what's going to play a role for the Gama. Gama equals 1. You can always implement error de Broglie. But the Gama equals 1 is like pledging a human capital. It's like slavery. Constitution don't let you to do that. Gama is 0.2 is like Monday you're a slave, something like that. And then the rest you're free. Not really slave, but your incomes are automatically seized. And that's a delicate point that I want to emphasize, because that's what society debate about. How much can you garnish from people? Because you have just exposed, right? After you're going to garnish everything. And then the bad state happened, judge don't let you to do that. And legislator, knowing that, they don't let you pledging so much of income because of it's not implementable. And so I think it's a very important social issue. I thought it was in Brazil, but in the West, everywhere. So but the problem here is non-concave. Felix went away already, right? So now I'm free, because he said that I cheated on convexity, but it's not. He knows that I didn't cheat. But anyhow, this is a big problem, okay? That's what he made a joke, right? But anyhow, I'm more free now he's gone. Because this is a concave problem. So the budget set is non-convex. That's why me and Mario have a continued number of people and so forth. But to simplify, you calculate cases where equilibrium still exists, although there's a danger there. But, so what's the budget set? In the first period, the budget set is you buy goods, sell endowments, buy secured, sell secured, buy and sell unsecured. And you have collateral constraint. So that's what's different, okay? In order to sell this asset, you have to buy collateral and put that as a guarantee of your loans. Quite realistic from real life. In T equals 1, there is S periods. And that's what the budget constraint is, like that one to buy. You sell your durable, you sell your endowment, you buy goods, and then have to pay back some of your debt according to that rule there. You might want to go bankrupt, whatever. And here, that's what your income from financial. And then you have a bounding constraint, borrowing constraint. Sorry. Then this example here comes from my paper with Susan and Felix. So the important thing is the endowment. The utility function is something simple. And there are two goods, right? You like the durable and the perishable. And here you have 4 of the perishable, and the durable is 4 units. And the second guy gets eta%, and the first guy gets 1 minus eta. And there are 2 states of nature. And the state of nature, we have only the perishable, no more durable, because the word finish after that. The endogenous I compute here, first you run that as an arrow the brew economy, find the endogenous price, and that's the optimal collateral level. That's a bright idea of John Donacopoulos, okay? Endogenous collateral. So the return matrix is this. The first thing, don't get mixed up, because, oh, this return matrix is full rank, so it's a complete market. No, but in order to operate in this economy, you have to constitute collateral. So that's... so even distribution is supposed to have eta equals half. The arrow de Breuer allocation is like that. The portfolio of the arrow de Breuer is this. That supports the arrow de Breuer allocation, that you want to buy and sell assets of contingent claim in this way. That's for the arrow de Breuer. Can I support the arrow de Breuer? And then I look to have just that much of just now to operate in this Z level here of assets, buying and selling, I have to constitute collateral. And that's what the amount of durable that I decide to buy in the arrow de Breuer case. So that has to be positive. If not, don't implement arrow de Breuer. And it has to be positive. So in this case here, I implement arrow de Breuer. Everything is fine. So although all these financial constraints, in this case here, I still have arrow de Breuer. But now, suppose I have another stream, and all the durables belong to the second person. And then the arrow de Breuer allocation is like that. For the first person, the second, each state of nature, of durables and perishable and so forth. And the required portfolio to generate that, if I am arrow de Breuer, I'm fine. But now I can do that only with collateral contracts. And then I get a negative number here. So the arrow de Breuer is not implementable. Now, suppose agent 2 now, suppose now asset 1 is unsecured. So asset 1, you don't have to put up collateral. Then, if I put a big enough gamma, if I put gamma equals 1, I can always do, because the guy is be afraid of losing everything, so he's going to pay back. That would be like putting your human capital as collateral. But if gamma is bigger than this number here, the Breuer is feasible. It's still not chosen because there's a little work more. But anyhow, it's something around that. It had to be a little bit better, not only be feasible, but to be chosen. But, so there is a gamma. It's very intuitive. And what's happened here? This case here is me and Susan and Felix, okay? I implement arrow de Breuer, depending these two parameters. How much you like the durable, how much you like the perishable, alpha is how much you like the perishable. And here was the proportion of durable among people in the economy. Equal distribution of durable, that's the easiest part, okay? So I can implement the arrow de Breuer a lot here, lots of parameters. Now, but that's lots of parameters, but that's it. Sorry, not a lot, just this blue region here, okay? Now, if I introduce unsecured, I have a green and the red, unsecured and secured. Now, with the gray, if I put all unsecured, can always do it. But then the question is, how big is gamma? Is that realistic? So let's take a look at this question. So that's the minimum seizure rate to implement error de Broglie. It's not that bad for this case here, but I have to go up to here, 0.35, I don't know. So it's almost 40% of your income, quite a bit of slavery in some sense, right? So it's so that's but that's the type of question that I'd like to answer. Now let's make some numerical exercise for the U.S. economy. I'm going to sort of not calibrate, but illustrate the U.S. data. There are 4 agents, endowment match U.S. income and wealth distribution in 2007. This guy, at the end, this thing here comes from the Fed, some Fed, I think, New York, I don't know. But they work a little bit on that. And then you have some data on social mobility, because this thing also, a person might be very poor, but then become my wealthy next year. So he can borrow unsecured, that's fine. Because he's so wealthy, he doesn't want to be his income garnished. So you might get error de Broglie because he's a student, no? Like a student, get a student loan, and then he pays back without problem. So the social mobility plays a role, no? It's not social mobility, it's just young and old, it's not so, anyhow, I give this name, social mobility, don't get, I gave already this paper, that's not social mobility, okay, but anyhow, still call it, until we change. So we have 3 states of nature. In the first one is a status quo. Agents, so there is today and tomorrow, and then your income and wealth change. So one is status quo, so everything stays the same. Here the age 1 to go to 2, 3 to 4, and vice versa. So 2 to 1, 1 to 2, 2 to 1, 3 to 4, 4 and 3 is more social. 3, 4 jumps to 1 and 2, and vice versa. Okay. So this is the data from the U.S. The agent 1, the wealthiest people in the U.S., has 84% of the durable and 61% of the perishable. Perishable is labor income. Durable is like wealth. Agent 2 is 22% of the perishable, the current income, and 12% of the durable, and so forth. The agent 4 just have 5% of the perishable and 0% of the durable. Some of them are actually net wealth, negative wealth, because this is for the quartile. No, and then put in the state, there's 1, 2, and 3, the state of nature. No, 1 is, here is status quo, everything remains the same, and the other have some mobility. And now we try different probabilities. So probability P of status quo, 1 minus P minus epsilon is the second state, and epsilon is the most social mobility. And so what happened if gamma equals 0, no unsecured assets traded is equivalent to secured economy. The work that I did with Felix and Jet, no, we get that much utility. That's percentage of utility in terms of the utility in error de Broglie. Now, for a different model, a little different model, we get with 0.7 error de Broglie allocations implemented. But it's pretty high, right? So it's not, no court, no legislation let you to garnish 70% of your endowment of labor income, future labor income. So, so it depends on the poor agent. Increase social mobility would decrease the need of the social seizure rate. So how big need the seizure rate? So with P, with the status quo being very high, I need 80% in the U.S. economy. It's too much. But there are lots of student loans, so it's a big enough epsilon here, the seizure rate comes down. If you still increase the thing reverse, because then the poor become wealth and so forth. But anyhow, that's not interesting. So this is the, with epsilon, data show the epsilon is around 10%, so gamma should be between 0.6 and 0.8. At least according to this criteria, probably that's too high. That probably US don't live in an area of the broad economy. No? Probably there are other facts influencing, but the full equilibrium. Now suppose that the matrix has full rank. If the I cheat in some sense. There is important issue about the existence of equilibrium. Have all this non-convex? I didn't cheat. Felix Samuel was wrong in the first part. Because what I did is the gamma big enough so people never divided 4. And so you implement error of the Bro, then equilibrium exists, right? Because that's the error of the Bro. So, but that gamma is big enough. So suppose now I go to other range, or then I don't start with the full, with the complete marker, complete in the sense of there are not enough collateral contracts and so forth. And then this question of existence is very pretty, okay? Where Mauricio worked hard, he did it. But because you have all this non-convexity here. But the observation here is that the utility is not, since the budget set is non-convex, the utility is non-concave. But they are concave by regions. So I can compute the optimum here, and compare. Can still do it for simple case. But then I have to find some parameter space where equilibrium exists. So it's very careful, done, okay, but anyhow, I'm not going over it because it's very technical. I'll just give an example where varying gamma, and then I have two regulating parameters, gamma, no, but also m. If I put gamma equals 0.15, the best thing I can do, this is a negative number, so the smaller number is the higher the utility. If I put the debt constraint, then the best for the consumer for this gamma is to default in both states. If I put gamma is 0.25, the best for the consumer is to default in both states, and m equals this, and so forth. If I go gamma 0.55, then the best is not to default, no default. But the utility here is less than the case of default in two states. So you should never put a gamma that high in order to not let default in. Because I was putting gamma high enough to implement algebra, but in this case here, since market not complete. So it should not go that high in gamma, because the other got lesser utility. It's good to have some default here to stay. So that's some lesson I have had from this. So I don't want to continue too long, so I want to do this optimal contagions, okay? So contagion might be good. So don't take this primitive view, because there's people that work in contagion. It's not general equilibrium. It's beautiful in terms of network. They had big network, but there are lots of fixed things. Here, if you let things flexible, I'm fan of general equilibrium, you know that, right? But if you price things correctly according to market, the contagion might be good. So it should have everything to be endogenous. So this is the, for their model, contagion is undesirable. It's always bad. So exogenous is not, because exogenous prices are not informative about the market that lead to inefficient. It shows that price and portfolio are endogenous, contagious might be Pareto improvement. So endogenous price reflect the full probability that provide useful information for market allocation. So it's very simple. Network-wise, it's very simple. Just 3 agents. There is an intermediary. This guy here is a lender. He lends money to the intermediary, then the intermediary pays back. This KA here is how much he pays back. And here the intermediary borrows from B, Sorry, A is lender. So he borrows from A and lends to B. And then P pays back KB. So this is a variable to be determined in equilibrium. And then what's the problem of the problem of A and B is very similar to the one before that I showed quickly. But the intermediary like a bank, right? What a bank is, the bank is poor, right? The bank's borrowing to lend. So the bank doesn't have, it's not like a collateral, right? That you borrow and then have your house that's worth more than the collateral. But you need banks, no? So the bank has a linear utility. So his endowment in the first period, he has the capital of the bank, something like that. And he sells and buys assets. And then he pays back whatever he has. That's bank liquidation. His debt is bigger than his asset. He's liquidated, but he's left with zero utility, the banker, the second period. And that's subject to the budget borrowing constraint. That's his wealth, how much he borrows, how much he lends. So that's to be bigger than zero. And then here I put this condition here. So he doesn't borrow to eat, okay? He just borrows to lend. So he borrows less when he lends. That's very reasonable for a bank. So for small m, there is no default equilibrium. For big N and F, I fixed three possibilities. We have three equilibrium. Autarky, so everybody's pessimist, because I just think of people make forecasts about kappa. If you think nobody is going to pay anybody, the financial market collapse. That's always an equilibrium, okay? Autarky. Equilibrium without contagious, without contagious because XA is 0. It's cheating a little bit. It's a simple example, because you have to calculate this thing. In this case here, the banker doesn't have contagion because he doesn't borrow. But then there's equilibrium with contagion. He borrows, lends the intermediary, and there is some default. K is less than 1. And then, I'm not going to take much of your time, but then there's the equilibrium with default and non-contagious. Equilibrium with default and contagious. You see, this utility here is bigger than that. Why? Because here, agent A is only eating his endowment. Here, he's doing something else. Since here, he could have eaten his own endowment, that means that this is bigger than that. And here is the intermediary stay the same, and this here increases. And there's a little economics here, because he increases utility exactly because the price of the 4 is correctly made, because everything is endogenous. That's a general equilibrium. So, introduce unsecured and the pure collateral model increase the chance of implementing error de Broglie. So, we should do it. Just collateral. People don't understand sometimes, because to buy in collateral, you have to, you can never transfer income, wealth from today to tomorrow, because the collateral is always cost more than what you borrow. In mortgage, it's always, even subprime is 0 what you borrow, but you cannot borrow negative with the collateral. So you need another mechanism, as a debt card, credit card, or personal loans. That's a little bit, but that's play a very important role for a segment in the economy. Student loans and so forth. The minimum seizure rate to implement the bird depends on both endowment distribution and social mobility. Equilibrium exists without convexification, depends the seizure rate and the debt constraint. There are certain parameters where equilibrium exists. Incomplete market, therefore, and punishment should not be too harsh or too soft. That I'm saying with the gamma big, incomplete market, that example that I gave, you put a gamma too big, that's worse off. Choosing properly the seizure rate, the equilibrium no commit might be out of the Broglie with bankruptcy. So bankruptcy might be good in equilibrium. Actually, there is an example. It's not didn't put in this paper. It's in the paper, but not in the transparency. Well, with bankruptcy, we implement error de Broglie. We need loss of bank, and then we implement actually error de Broglie with highly incomplete set of assets. So we have to understand more about bankruptcy. Contingent equilíbrio might predominate the non-contingent equilibrium with endogenous price. It might dominate, not dominates always. Okay, might dominate. Okay.